Section 3.1, Law of Sines. All right, so both Section 3.1, Law of Sines, and Section 3.2, Law of Cosines, are dealing with the same concept. It is solving triangles that are not right triangles, so non-right triangles. Um, there's a list right here of things you need in order to use law of sines: the measure of one angle, the side length opposite that angle, one additional measure, which is either a side length or an angle. You just need to know one additional piece of information. Um, so there's a few different situations in which law of sines is relevant, is useful. And I want to say I never go by these names here. I don't name the triangles when I'm doing them, but you might remember this from like a geometry class sometime in your past. Side angle, side angle angle. We all make the joke, right? Like, oh, why not angle side? And it could be. There's nothing stopping it from being angle side, except for high school teachers everywhere knowing that that would be a bad idea. All right, we'll move forward. So the times when you can use it are going to be times when you know the uh, opposite side and the angle. So like I know the side and I know this angle. Um, and let's see. I'm gonna really quickly label these triangles. I'm just gonna give it like an A, B, C, A, B, C, A, B, C. So those are the angles. And then the way we name these, remember, is that the opposite side length, the side length and the angle opposite it are the same letter, but uppercase for angles, lowercase for side lengths. So this will be side A because it's opposite angle A. This would be side B because it's opposite angle B. This would be side C because it's opposite angle C. So uh, we need to know, let's make a better circle, a side and the angle opposite it, and then an additional piece of information. So that information could be a side. So in this case, we know B. So that's enough. Um, and if you look over here in the side angle situation, label those sides as well. A, B, C. In this situation, once again, we know an angle, an angle and a side opposite it. But the additional information we are given this time is another angle. So in the first one over here, you know their additional information is knowing a side. Over here, your additional information is knowing an angle. And then here, for this middle one, you might say, Professor Cook, this does not work because you don't know those, you don't know those, and you don't know those. So I don't think that we can do what you're saying we can do here. However, just because it's not obvious doesn't mean it's not determinable. So this is dun, 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 a very secret angle that we have here, right? We can find this angle. If you know two angles in a triangle, you can find the other. It's just 180 degrees minus the other two angles. Easily found. So you really do have that angle because it could do 180 minus the other two. So you have, boom, both of those. Um, and what I want you to notice here, so in each of these, it's the letter and its lowercase version, right? It's C in all of them, but it's the capital letter and the lowercase letter. So the way I really like to think about law of sines is you need to know everything about one letter. So it could be that you know everything about the letter B. So you know this angle up here and this side length down here. Maybe I'll use this picture here. It could be that you know everything about angle A, and then you have one additional piece of information, everything about C, everything about B, but that's the giveaway that you should use law of sines. And I'm telling you this because there are two different ways to solve non-right triangles, and each situation only applies in certain cases. And so the way I want you to internalize the situations in which law of sines is useful. Law of sines is useful if you know everything about one letter. You know side and its opposite angle, and you know one additional piece of information. So the law of sines itself is a simple formula. So it's a three-piece formula that you can also flip upside down. These are just ratios equal to each other. The sine of the angle A over A is equal to the sine of angle B over B. Really cool, really nice, straightforward formulas here. But you're only ever using two pieces of the law of sines at once. So like you might use a sine of A over baby A is equal to sine of C over baby C. You're only setting two of these equal. And then down here, you could set any of these equal to one another. So any of those can be set equal. Examples here and here. Again, you want to know everything about one letter in order to use law of sines. Sometimes it's obvious. Sometimes it's like, all right, I'm given angle A. That's too big. I'm given angle A. I'm given baby A. So I have big A, baby A. I know everything about A. I'm given angle B and baby B. So now I know everything about B. But the less obvious situation is given angle B, A. Ooh, let's do given alphabetical angle A, angle B, and lowercase c. It doesn't look like we know everything about anything, right? If you see this situation, you might say, well, you can't use law of sines here. You don't know everything about a letter. However, you secretly know angle C because you know two angles in the triangle. So you also know angle C. And because you know angle C, that's sufficient information. You have baby C, you have big C, you know everything about C. Boom. All right. So with these formulas, your goal is going to be either solving for a side length or solving for an angle, and which means you'll be rearranging these formulas a lot. And I just want you to get a little bit comfortable with how this rearrangement works. Um, Now, this could be tedious. So I'm going to go through each step on each of these problems, just because if you're watching this as a video, not like you're being forced to sit through it. You're only watching it if you need it. So I'm going to go step by step for these. Feel free to just skip to the end of the video because we move on to the next section after these problems are done. So if you want to just know what the answers are, skip to the end of the video, but I'm going to go through these each step by step. All right. So solve for the indicated variable when you have that given information. Here we know we are trying to solve for baby A. We know baby B, angle B. So the things that I know both of, so I know everything about B, those are going to go on the right hand side. The know everything about. So both the numerator and the denominator are going to be B's. I want to put the thing I'm trying to solve for up top here. So I am trying to solve for baby A. So I'm putting that up there, which means that the orientation of this will be baby letters on top, big letters on bottom, and it's sine of angle B and sine of angle A. In order, let's see. Don't want to move the arrow. In order to solve for angle A, not angle A, side length A, I'm going to put you here, duplicate you, move this over, delete a few things. Oh, I love technology. In order to solve for A, I'm going to multiply both sides by sine. And you want to get real good at this math. Like this math should start to become instantaneous to you. I'll multiply it up here. Those signs will cancel. You're left with A is equal to B sine of angle A divided by sine of angle B. Boom. All right. Solve for, you know what? I'll come back to that one. Let's do the angle one. Solve for C, going straight down here. Angle C. So the thing I want is going to go right, oop, that's too thick. There you go. Is going to go right up here. Since this is a capital C, we're looking for sine of angle C. And then that would be over baby C. On the other side goes the thing we know everything about. We know everything about baby B and big B. So sine's on top, sine of angle B over baby B. To get sine of angle C by itself, I would multiply both sides by C. You get sine of angle C is equal to C times sine of angle B over B. In order to get angle C all the way by itself, you would take sine inverse on both sides. We know that angle C will be an acute angle, so we don't need to worry about there being any issues uh, with the domain. These will what I'm trying to say, these will cancel out. This sine inverse and the sine will cancel out because we know C is acute. That's a rule we have. Those cancel. We're left with angle C is equal to sine inverse of C sine B all over baby B. And so what you're going to notice with these is for the side lengths, it turns out to just kind of be like a fraction. And then for the angles, it'll always be sine inverse of something, sine inverse of something. I want you to also notice that over here, you never have the same letter sitting next to each other. So this is like side length C, angle B, side length B, angle A. You only have, you always have the letters up and down from one another. So if you, because I have myself made that mistake while doing problems, um, just the mental math goes askew. What will tip me off is when I see these two letters next to each other. I'm like, wait, law of sines. I should never have the same letter next to that angle there. All right. So solve for side length C. You know everything about A, baby A, big A. So we know we can use law of sines because we know everything about A, and we have an additional piece of information. I am solving for C, so baby C. So that will go on top, which means the sines go on the bottom, sine of angle C. A is on the other side, so we'll do baby A on top, sine of angle A on bottom. In order to get, I should start moving these over. In order to get baby C by itself, multiplying both sides by sine of angle C. Boom, boom. You get that baby C is equal to A sine of angle C over sine A. Right? You want this to become really just kind of automatic math where you don't even have to write it down. The goal is to not have to write it down or to write down the most minimal amount of information possible. All right, we're solving for baby B. Baby B goes up here. Means that sine of angle B will go down below. The thing we know everything about is A. So we have side lengths on top. Baby A goes on top. Sine of angle A on the bottom. To get B by itself, baby B, multiply both sides by the denominator, sine B. These guys cancel on the left-hand side. You're left with B is equal to A sine of angle B all over sine of angle A. Two more. I put too many of these examples on here. That's okay. Two more. So we have sine of angle A will go on top because we're looking for angle A. We're able to use law of sines here because we know everything about C. We know little baby c, big C. So that means we can use law of sines. Baby A will go on bottom. So that means sines are on top. Sine of angle C over baby C. I want to get sine of angle A by itself. I will multiply both sides by A. Boom, boom. We have sine of angle A is equal to, I'm going to put the A out front, A, multiplication for this step, A sine C divided by C. To get angle A by itself, we take sine inverse on both sides. We get that angle A is equal to sine inverse of A sine of angle C all over C. All right. Solve for B, angle B. Oop. So we have sine of angle B over baby B. And then the thing we know everything about is C. We know baby C and big C. So sine of angle C all over baby C. To get sine of angle B by itself, multiply by B on both sides. You get sine of angle B is equal to B times sine angle C divided by C. To get angle B by itself, sine inverse on both sides. Boom, boom. Angle B is equal to sine inverse of B sine C divided by C. And there you go. So in all of these scenarios, I just want you to pay attention. Never is it like two B's on top, right? We're always going to have the thing we know everything about. One will be on top and one will be on bottom. But yeah, there you go. All right, so then if you want to know how to actually do the law of sines problems, that is in our next video. So I'll see you in that one. Bye.